A, D, D, E. Okay, there are 4 bytes on this one address. The pop operation just removes this. For example, if we pop this that beef, then ESP is added with 4. So ESP will again go back to here, and this value is not removed, but it stays here, but it will not be used. Right. Okay. Here's the x86 assembly language. Have you learned this? No. Okay. For the data transfer, have you learned assembly languages? Any, like ARM or MIPS or x86? No? Okay. For the data transfer instructions, there is move, like from move EBX register to EAX register, and what does this mean? It moves 5 to the memory pointed, the memory with address as EAX. So 5 is moved to the memory. This is the memory with the address. EX is the address of this memory. Right. And push EAX means we subtract ESP with 4, or subtract ESP with 4, and then puts the content in EAX to the top of the stack, right? Okay. And pop EDI means we first move the top of the stack to EDI register. For example, pop for this stack, if we execute pop EDI, then this value will be stored in EDI, and the stack will decrease for 4. Right? The cell pointer points to here. Is it clear? Okay. And Li means this is very simple. Just if this instruction equals to EBX plus 4 multiplies ESI, and store the value to EDI. This is for register operation, arithmetic operations. There are arithmetic, and logic instructions like add, addition, subtraction, increase and decrease. For example, increase EAX, then EAX is increased by 1, decreasing EAX, then EAX is decreased by 1. And multiplication, division, AND or XOR operations, and not negative, and shift left, shift right. Yeah, it's okay if you don't know the exact meaning. Just check Google it when you encounter these instructions. And there are also control transfer instructions like jump. For example, jump to 1, 2, 3, 4, 5, 6, 7, 8. Then the instruction pointer points to 1, 2, 3, 4, 5, 6, 7, 8, and it will execute the instructions at that address. And compare and jump condition, which means, for example, compare EAX and EBX. Jump J, for example, JE. Compare EAX, EBX, JE some address. It means compare the value in EAX and EBX. If EAX equals to EBX, then we go to this address. And call and return, this is used for functions. For example, we call this address 1, 2, 3, 4, 5, 6, 7, 8, which means we move this address to EIP. What is EIP? The instruction pointer. So we go to execute the instructions at 1, 2, 3, 4, 5, 6, 7, 8. And then we move the next instruction. Move the address, the next instruction address to the stack. For return, it moves the stored return address to EIP and then decrease the stack. I'll explain everything later on with a demo example. And there are two kinds of notations. One is called Intel syntax. This is Intel syntax, and this is AT and T syntax. They are the same, but for example, here it moves 8 to register EAX, and here it's in reverse. It moves 8 to EAX. L means long, which is 32 bits. And it moves FF to EBX. And this moves FF to EBX register. Int 80. Int 80 means system call. And it moves the content at address ECX to the register EAX. Here the same. Calling convention. I'll show you how functions are called in assembly code. You feel okay? Or it's too difficult, or I'm not explaining this clearly? Okay. Let's go. I write a piece of C code which is very easy. As you can sorry. Wow. Here's the code. In the main function, there are two local variables, integer a and integer b. And then a and b are passed to this function add. Function add will add the past A and B and return the sum of A and B, and then we print the value. Okay.
Just a small question. The return type of the add it should be integer or char?
Add type.
Oh, sorry. Yeah.
Yes.
Yeah. Okay. Let's compile it. Okay. Here is the output. The output is. Oh, sorry. I'll compile it to 32-bit machine. And with debugging information. Okay. What? And yeah, you can see it's 32 instead of 64. Let's see the assembly code. We use obj dump to disassemble this executable file. Well, I prefer, by default it is AT&T syntax. You can see, yeah, it's AT&T syntax, right? But I prefer Intel syntax, so I specify this. Yeah, and let's see how the functions is called. Here is the main function. Here is the add function. Okay, and yeah, let's start to execute the main function. First, we push EBP to the stack. I'll draw the stack. Let's get the real value of EBP at here. We say debugger, okay. I use GDB, and we set a breakpoint at this address. And then we run the program. It will stop at here. Okay, done. Let's see what's the value of EBP at this address. So EBP is 0. 0. This is the stack and high address, lower address. Then let's execute the program. Move ESP to EBP means the value of ESP is moved to EBP and ESP is here. So ESP is EBP, ESP. ESP is CF, AC. Then the value is moved to EBP. And there is an AND operation for ESP. After the AND operation, so what's the ESP and zero? What's the output? So it's 0, A, F, C, F, right? Why there is such an operation?
0, 1.
Because
That's the space for the stack.
the CPU wants to align the ESP to 16 bytes. So, for example, if ESP is AC, like AC, after this operation, it points to A0. Okay, and the CPU will fetch every 16 bytes or 4 bytes in the memory. So this is just to align this to every 16 bytes. And then we subtract ESP with the